Hello and welcome to Mathematical Coaching Center. Today in this video we'll be proving one theorem related to angles in a circle, and this is the fourth part of the video, and if you have not seen the first three parts, the link will be given in the description. But before we begin, my name is Umang Khawas, and if you have any problem in learning mathematics, then consider subscribing this channel. So without any further ado, let's begin and see the statement of the theorem. The statement of the theorem states that the opposite angle of a cyclic quadrilateral are supplementary. Okay, so here we have the term quadrilateral. So quadrilateral is any figure which has four sides, and a cyclic quadrilateral means a quadrilateral whose vertices are on the circle, okay, whose vertices lie in the circle. And if we have such kind of a quadrilateral which is lying on a circle, whose vertices lie in the circle, the opposite angles will be supplementary. Supplementary means the sum is 180 degree. Okay, sum will be 180 degree. Now let's understand this with the help of a diagram. So suppose there is a circle with a center O. Now if we choose 4 points A, B, C and D, and if we draw a quadrilateral, so we have figure having four sides. So side AB, BC, CD and DA, these are four sides, and this is a quadrilateral. Since this vertices lies in a circle, so this kind of quadrilateral is known as a cyclic quadrilateral. Now the opposite angle, that is this angle here and the angle here, these two angles will be supplementary. That means the sum of these two angles will be 180 degree. Not only this, but the angle here, okay, and the angle on this side will also give the sum to be 180 degree. So this is what the theorem states. So to prove this theorem, we'll take help of another theorem or result. Okay, so let's see what is the result that we will be using. The statement of that theorem states that the angle subtended by an arc of a circle at the center, okay, there will be a circle at the center, and it will be double the angle subtended by it at any point on the remaining part of the circle. So this angle at the center will be double the angle at the circle. So if there is a circle with center O and there's any 2 points A and B, and if we draw an angle at the center taking the help of these 2 points A and B. Now again, if we draw another angle at the circle, remaining part of the circle, so here we are choosing any point C and we are drawing an angle here. Here we are choosing any point C and we are drawing an angle here. So the angle that is at the center, that is this angle here, will be double the angle that is in the circumference of the circle. Okay, that is this angle here. That means we can say that angle AOB, that is the angle at the center, is equals to 2 or twice the angle at the circle, that is angle ECB, because it is double the angle at the remaining part of the circle. So this is the result that we will use to prove our theorem. Okay, so let's come back to the theorem. So the statement says that the opposite angle of a cyclic quadrilateral are supplementary. So what we will write is that O is the center of the circle and ABCD is a cyclic quadrilateral. So that is what we will write in given. So given ABCD is a cyclic quadrilateral of a center of a circle with center O. Now what are we supposed to prove? We are to prove that the opposite angle will be supplementary, that is 180 degree, or you can also say two right angles. So that is angle ABC plus angle ACD, that is angle ABC is this angle here and angle ADC is this angle here, that will be equal to two right angle. Okay, so this is 2 into 90, that is 180. Okay, so this is 2 into 90, so we can also say it to be two right angles. But not only that, we also need to prove that angle BCD, that is this angle here onto this side, plus angle BAD, that is the angle onto this side, will be equal to two right angle. So to prove this, we'll do a construction. So in construction, what we will do is we'll try to create an angle at the center. So to do that, we'll be joining OA and OC. So we'll join OA and OC so that we have a angle at the center. We have the angle at the center. So let's proceed to the proof of the theorem. So now first what we see is that the reflex angle AOC is the angle at the center. That is, reflex angle AOC is the angle at the center, and ABC is the angle at the circle formed by the circular arc ADC. Now this arc ADC, that is this part, forms an angle at the center, that is this angle here, and this angle is reflex angle AOC. And this arc also forms the angle at the circle, and that is ABC. So we know that the angle at the center will be twice the angle at the circle. So reflex angle AOC is twice angle ABC. Okay. Similarly, we can see that angle AOC is the angle at the center, and angle ADC is the angle formed with the circular arc. This is the angle at circle formed by the arc ABC. So this arc forms the angle AOC, that is this angle here at the center, and this arc forms an angle ADC at the circle. So we know that angle at the center, okay, so this is the angle at the circle. So we know that angle at the center is twice angle ADC, that is angle at the circle. So these are the two important things that we derived with the help of this diagram. That is, reflex angle AOC is twice angle ABC, and angle AOC is twice angle EDC. Now what we will do is we will add this angle to ABC and ADC. So 2ABC plus angle EDC will be equal to reflex angle AOC and AOC. So this is what we have now. Now taking out 2 common from the first part, we have from the left hand side, taking out 2 common, we have 2 into angle ABC plus angle EDC. Now this angle, reflex angle, adding reflex angle AOC and AOC, we see that we get a complete angle, and the measurement of complete angle is 360 degree or 4 right angles, because this is 4 into 90, that will give us 360 degree. Okay, so complete angle, the measurement of complete angle is 360 degree, and that is what we get after adding reflex angle AOC and angle AOC. Now cancelling this 2 with 4, we have angle ABC plus angle ADC is 2 right angles. So this is what we need to prove, that the opposite angles, that is angle ABC and ADC, the sum will give us 180 degree. So the angles are supplementary. So this is the first part of the proof. So the next part, we need to prove that this angle here, that is BAD plus BCD, will also give us 2 right angles. So to prove that, what we will do is, similarly we'll be joining OD and OB. So we'll be joining OD and OB, and proceeding as before, that this is the angle at the center and this is the angle at the circumference. So it will give us angle at the center will be twice the angle at the circle. Again, this is the angle at the center, this part, and this is the angle at the circle. And by adding this 2, we'll get that this angle will be 360 degrees. Sum of this angle will be complete. So by proceeding as before, what we will get is angle BCD plus BAD will also be 2 right angles. Okay, so finally what we get is angle ABC plus angle ADC is 2 right angle, and BCD plus BAD is again 2 right angle. So that means the opposite angle of a cyclic quadrilateral are supplementary. So this is how we prove this theorem. I hope that you understood the proof of the theorem. So to stay updated with our channel, subscribe to the channel and turn on the notification bell. Thank you for watching and have a good day.